In this video, I'm going to demonstrate the equivalence of partial eta squared for an interaction term derived from a 2x2 factorial between subjects ANOVA, which I suggested is interpretable, and an interaction term derived from a multiple regression analysis. So again, the reason I'm doing this, as I mentioned in the textbook, is that I think the interaction term in an ANOVA is kind of interpretable, specifically the partial eta squared. So just to recap, these data set are based on the video game study, and it's the equal sample sized one. So it's the one where I get rid of the issue of unequal sample sizes and heterogeneous variances. So in this case here, the sample sizes are equal. So just to show you what the partial eta squared is in this analysis, so we've got punishment in the dependent variable box, game type and sex in the fixed factors, and click on options, and we want estimates of effect size. Click continue and click OK. And this will give us the partial eta squared that we want. And in this case here, the interaction term was not statistically significant. Recall in the textbook that once you went from unequal sample sizes to equal sample sizes, the interaction term lost its statistical significance. In this case, we have an F value of 3.546, P equal 0.070. And importantly, we have a partial eta squared here of 0.112. And I'm just going to push that out a little bit because it's going to help me do an analysis to compare it to the multiple regression, which people do not argue with the suggestion that it represents unique effects. So the interaction is not significant, but the partial eta squared is pretty good. 11% of the variance in the dependent variable was accounted for by the interaction term, excluding the effects of game type main effect and sex main effect. True, it's not significant, so I can't interpret it as so, but that's what the value is. So now to show you the multiple regression context of this, I need to multiply these two variables together. Now, as I mentioned in the textbook, I assume you have some familiarity with multiple regression and partial correlation. This is an advanced topic of the chapter devoted to factorial between subjects ANOVA. So I'm going beyond the foundation section, I'm even going beyond the chapter. So if you don't know multiple regression and partial correlation to some degree, this will probably be beyond you. But to calculate the interaction term in a multiple regression, I need to create a product term out of my independent variables. And I can do that pretty easily through the transform compute utility. And I'm going to call it the product interaction. And I literally just have to multiply the two independent variables together to obtain the interaction term for this analysis. And then I just have to include this variable inside the multiple regression analysis. So these will be my two main effects, and this will be my interaction effect. And of course, this is the dependent variable in the multiple regression context. Going to analyze regression linear, and I put punishment into the dependent variable box, and I put game type, sex, and product interaction term into the independent box. Now I also want to get some statistics here. Specifically, I want part and partial correlations. As I mentioned in the multiple regression chapter, I prefer to interpret multiple regression effects from the context of part and partial correlations. And I'm going to show you a direct correspondence with partial eta squared in the ANOVA context. So I'll click on OK, and here are the results. We can see here that the multiple R was associated with an R square of 32.5 or 0.325, which suggests 32.5% of the variance was accounted for in aggression levels by the model, and it's statistically significant, that R squared value, P equal 0.011. Now importantly, if you go down to the individual predictors, which includes the main effect of game type, sex, and product interaction, over here I've got a p-value of 0.070. Now if I push that out, that should ring a bell. It's similar. Push it out to 6 decimal places. I get a value of 0.070127. Now if I go back to the interaction obtained in the ANOVA and push that out, I get exactly the same p-value, 0.070127, 0.070127. Correspondingly, if I squared this t value, 1.883 squared equals 3.54, and that corresponds to the f value in the ANOVA. That's not a coincidence. As I mentioned, there's a direct correspondence between these two effects, the interaction term in the ANOVA and the interaction term in a multiple regression context. Now, the advantage of the multiple regression is that people are familiar with the idea that you can interpret partial or part correlations or semi-partial correlations. Now, if you look at this partial correlation of 0.335, keep that in mind. I have a partial eta squared here of 0.11240. And if I square root that, because this is in a squared format, whereas a partial correlation is not, 0.11240 square rooted 0.335, and that gives me the 0.335. And that's not a coincidence. So that's why I suggest in a textbook that the game type bisects interaction term in the ANOVA, specifically the partial eta squared, might be interpretable in comparison to the eta squares associated with the main effects. So take that as a consideration when you are conducting a factorial between subjects ANOVA.